Hello everyone, how are you all? I hope all of you are doing fine and following the concept of sequences. So what we have done so far, we have introduced what are sequences in mathematics. We have introduced the type of sequences, convergent, divergent and oscillatory. Then we discussed the definitions of a convergent and a divergent sequence. We also found a relationship between convergent and bounded sequence. Now today we will do a very important thing, that the limit of a convergent sequence is always unique. That means if a sequence is converging, it will converge to the same value for all the people who are calculating the limit. So we cannot have two different limits. And how are we going to prove it? We are going to prove it by contradiction. That means by assuming the opposite. All right. So again, let us consider a sequence. Okay. So assume that AN is a convergent sequence. Okay. And assume that AN is convergent to two different limits. So assume that limit n tending to infinity AN is L, and also assume that limit n tending to infinity AN is L dash, where L is not equal to L dash. Okay. So now choose epsilon to be mod L minus L dash divided by 2. Because L is not equal to L dash, so therefore mod of L minus L dash will be a positive number. So this particular thing is a positive number. Okay. So now what have we done as per the definition of a convergent sequence? So as AN is convergent to L, given this epsilon positive, there exists an M1 belonging to the set of natural numbers such that distance between AN minus L is less than epsilon. Okay, so the distance is less than epsilon. Also, as AN converges to L dash, given epsilon positive, there exists M2 belonging to N such that the distance between AN minus L dash is also less than epsilon. All right. So, or what we can do that for this epsilon, this distance can be made less than epsilon by 2. Similarly, for this epsilon, this distance can be made less than epsilon by 2. So the distance between the term of the sequence and the limit that we're talking about has to be less than epsilon by 2 for some M1 natural number and for some M2 natural numbers. And this is going to happen for all n greater than or equal to M1. And this is going to happen for all n greater than or equal to M2. This is by the definition of convergence of a sequence. For every epsilon, we get a natural number. So basically, if we choose M to be maximum of M1 and M2, then these two inequalities will hold together. That means AN minus L mod is less than epsilon by 2 and AN minus L dash mod is less than epsilon by 2 for all n greater than or equal to M, where M is the maximum of these two particular numbers. All right. Now, let us look at something. So, mod L minus L dash, it can be written down as mod L minus AN plus AN minus L dash. What I have done, I have added AN and subtracted AN. Now there is something known as triangle inequality. According to triangle inequality, mod A plus B is always less than or equal to mod A plus mod B. Therefore, mod L minus L dash, now this is A and this is B. So mod L minus L dash is less than or equal to mod L minus AN plus mod AN minus L dash. So this mod L minus L dash is less than or equal to, now what is this mod L minus an? I can write this as mod an minus L, because mod will absorb the negative sign, and this is an minus L dash mod. So now we know that we have already assumed L minus L dash to be something that is 2 epsilon. Okay, so this is a 2 epsilon. This is less than or equal to. Now an minus L mod is less than epsilon by 2. So therefore we will have a strict inequality sign. So we will have epsilon by 2 for all n greater than or equal to m. So 2 epsilon will be less than epsilon for all n greater than or equal to m. And this is a contradiction. And since we have reached a contradiction, our assumption that L was not equal to L dash was wrong. Hence, L is always equal to L dash. So we have come to a very important conclusion that a sequence, if at all converges, will always converge to the same limit. Therefore, two people attempting the same question will not get different answers. So I hope you understood the concept really well. It is a very important concept for convergent of sequences. See you in the next class.